Okay, so today we'll be designing Bitly. Bitly is basically a service that converts a long URL into a short URL and also give us like analytics about the shortened URL. Okay, so let's start here with the functional requirements. Okay, so first we want to be able to create a, a short URL from a long URL. We also, well, we want to redirect users from the short URL to the original URL. And also we want to view some analytics and metrics about the shortened URL. Then let's see our non-functional requirements. So in this case we are looking for extremely high availability over consistency. I think if the user has to wait like some seconds to see the redirect from the original from the short URL to a long URL, it won't be a very big deal if it has to be like some milliseconds or even or seconds. But we want to ensure that our system will be always redirected. So we are looking here for a high available system. And we also want to ensure like extremely low latency every time we want to perform a redirect. I think with less than 200 milliseconds, I think it will be very fast. Okay. Okay, so since we are creating a short URL, we want to create like a very short code, like I think like with 6 characters or will be okay. So and also we have to ensure that this is like this code is unique, so we do not have any trouble when we want to redirect. Well, okay, then let's see the core entities. So we have like a long URL, a short URL, a user, and I think with that we are done. Then the actions, well, we'll be using designing this with an API REST. So if we want to create a short URL, it will be paused. And in the body we will send the original URL. Okay, then well, if we want to be redirected, it will be also a get operation. And we also, if we are the person that creates the short URL, we want to view some metrics, analytics about that short URL. Okay, so with that we can start with our high level design. I will start as simple as possible and then we'll see what changes we have to make to scale this. Okay, so we have, let's say, a user that performs a request to a server that will be in charge of handling the redirect and the creation of short URL. So it will be our primary server. And we'll have an SQL database, and there we will store all the short URLs. So in the SQL we'll have a table, a URL table that, well, it will have short URL, the original URL, the user, the creation time, and things like that. And okay, so first we want to create a short URL from a long URL. So we have to perform like some hash operation or encoding operation to create a short URL. So we can, I think the easiest and the simplest way to solve that, we can have like a counter that will be, for now it will be in memory, and every time we create a counter we increase one, and that will be like the code of our original, of our short URL. But if we want to create like, we have like a limit here, because since we have like just six characters, our limit is 1 million 1 million short codes. So if we scale to billions of users, it will be a very big problem. So how can we solve that? We can use like base 62 encoding. Basically we'll have our counter, our number, and we'll encode that with base 62, that is basically encode by using, considering all the digits, and also include the alphabet from A to C in lowercase and in uppercase. So if we want to have like 6 characters, we can store like 50 billions or something like that of short code for our short URL. So I think with that will be enough. So I will draw here a counter, but that for now will be in memory. Later we'll see if we need to change that. Okay, so we create the short URL, the code here, and we store that in the SQL database. And if we want to redirect, okay, if we want to redirect, we have here like 2 different options. You can use a temporal redirect or a permanent redirect. So what's the difference? If we use a permanent redirect, the next time the user that want to access the original URL through the short URL, our server won't process it and will be directly to the original URL. So that will be a problem, because one of our functional requirements is analytics. So we want that our server process every time a user perform a redirect operation in our short URLs. So in this case I will use a temporal redirect, that is an HTTP, the code is HTTP 302. We want to see analytics about a shortened URL. So for that, we can use a database that is specialized for analytics, performing aggregations in the database. So I think in this case I won't use the same SQL database. I will use a different one that is we can use like BigQuery. And every time we perform a redirect, we up, update the BigQuery database and we look for the short URL. So with that, we cover all the functional requirements. Now let's see our non-functional requirements. We want to have like a high available system. Okay, so the first problem that we can encounter here is that our server is our single point of failure. So if that server crashes or it receives like dozens of thousands of requests at the same time, it might not support all that workload. So we want to scale that horizontally. But we have a problem here because we have a counter that is in memory. So we have to move that counter to another place. We can use Redis that supports that supports like the counter, like it's built in, and it also helped us to solve the problem that two different servers have exactly the same counter. So it's single threaded. We won't have that problem. And since we can notice something here, that we have two different operations that handle different needs and different non-functional requirements. We have first the redirect operation that is very read heavy, and well, the operation of creating a short URL that is not read heavy. So they handle different needs and requirements. So we can separate those into different servers. So we can have like here the redirect server, and we can have here the it will be like the write server, and we can use here like an API gateway. And the counter, of course, will be the right server. It's the one that will be using the counter, since it's the one that creates the short code. Okay. And okay, so now we have our redirect has to have like a very low latency, less than 200 milliseconds. Okay, so the first thing that comes to my mind with this is using a CDN. So that seems to be a good option, but we have a problem. Since we are tracking analytics, we want to to process all the requests of redirects into our server. So I won't consider a CDN at this point. Maybe later we'll see. But we can solve that problem of performing like a dozen of thousand of requests at this SQL database uh, by using a cache. We have a cache here. Uh, and in Redis it's a key value database, so the key will be the short URL and its value will be the original or the long URL. And well, so we can use a cache aside pattern. So when we receive an operation to redirect, we first look to our cache if we have that key. If we have, we basically redirect. If we don't, we have to make we have to search into our database and update the cache, and then we redirect to our user. Okay, and with that, our redirect server can scale horizontally and can handle more and more and dozens of thousands of requests per second without any problem. Okay, so now let's see. We have a problem here. We can notice that every time that we are performing like a redirect operation, we are every time writing in the BigQuery, and since if we have like received like thousands of requests per second, our BigQuery database is not able to support that since it's not designed to be like write heavy. So we can solve that problem by using a queue to handle those peaks. Let's see. Um, okay, so let's see. So instead of making a write operation for every time we have an event, we send them to a queue, and then we can have like a buffer, like a server that it will have in memory like at least like 100 events of redirect. So instead of performing 100 writes, it will perform just one write. So with that, we can reduce the workload of our BigQuery database. Okay, so and the user that want to see the metrics about the shortened URL will access here. Okay, and last, to have like a system that is like completely available, We notice that we have a problem of a single point of failure in the database. We have just one instance that even though we handle like we solve those problem of many writes operations with cache, or even we can use a queue, but it's not the problem the writes. Uh, but we can add some replicas first because we want to have like a completely high available system, and we can also like solve the problem of the redirect server that is very high read heavy, even though we have a cache here. So let's see, we can have like our primary database, and let's see here. And we can have here the replicas, and the redirect server will be reading the replicas, and the write server will perform the writes to the primary database. So with that, we solve the problem of the non-functional requirement of low latencies by using a cache here, and well, we have also many replicas to perform read operations, and well, the short code by using the counter here. So with that, we are done. We are done.